All right. The past week, a couple of people have been out of town, so things have been a little bit slower than usual, although still pretty fast. Three new PRs for this week. There was a pretty new one hot off the presses. Fix broken unused calculation in Blue Store. Um, that is interesting, and I think probably Sage or Igor are going to have to look at that. But potentially that might save us some work. There's this other OSD one for changing the OSD OpQ cutoff default to high. I have not looked in depth at that, although there's a couple of people in the community that I guess are seeing better results with it. I've got a new PR that doesn't really affect performance in any real way, except that it makes it easier to diagnose where we are spending time in DuoSD ops. That currently is a giant switch statement with thousands of lines in it, and that PR breaks it up into smaller chunks, which just on one hand makes things easier to follow, but then on the other hand also makes it so that when you're doing wall clock profiling, you can kind of tell what op you're spending time in, which is nice. So I'm going to run that through QA today, hopefully. For closed PRs, we have this RGW change for max usage trim entries. I did not look closely at that, but Casey did, so looks good. Blue Store introduced fast automatic legacy statfs fix. That was one of Igor's PRs, and Kifu merged it. And then Rados bench sequential and random read. This was a PR that fixes some kind of bad behavior in Rados bench. And I looked at it and generally thought it was good. And Kifu looked at it and had some more additional feedback. And it looks like that must have worked out well because Kifu merged that as well. So in terms of updates, we've got some updates to Eric's changes for doing some smarter filtering in the OSD for RGW bucket listing. Let's see. Oh, this one for immutable small object within the O node. The idea here is that you're inlining really small objects. It does look like it's faster in the tests that were run, but those tests were only run for 90, I think it was, it might have been 900 seconds. But still, that wasn't that many objects. So I would very much like to see those tests run for much longer periods of time, potentially, if possible, up to like 64 million objects on one OSD. And I think that will give us a much better idea of what happens when RocksDB is starting to move stuff around between multiple different levels and kind of higher rate of amplification, which is what happens when you really fill it up with stuff. So that will be interesting to see. There's Sam's LTTNG trace points PR. I think he's waiting for a review from Adam on that. Majian Peng's finisher PR is still failing testing, so he's going to go back and look at that one. Adam's iObject and similar PRs are still in the works, but it looks like they're still getting updates, so that's good. Sorry about my phone. The MDS cache memory limit is still being worked on, needs another rebase, but hopefully it's close. Adam's sharding work, other Adam, that is going somewhat better. He discovered the issue that he was having that was causing rare seg faults. So he fixed that. But the other problem that he's hitting now is that RocksDB is corrupting itself in kind of unfortunate ways. And it's happening after not too much work. It's like 2.5 hours of work you can hit it. I think he was even getting that faster. It's possible that we are actually seeing this very rarely in master. It looks similar to some reports that we've gotten for just kind of random ones regarding RocksDB corruption. So it may be that he's hit upon a way to make this happen much faster, or it might be something totally different. But uh, he's still trying to figure out how to get this passing tests. Okay, there's a locking change from MyGMPeng and BlueStore. I need to go back and review our locking before I can offer any useful advice on that one. But there's that. And then another one of Adam's PRs for his work. So that's about it. Any questions on PRs or any PRs I missed that people are working on? All right. Well, I've got nothing else really set for today. So 14436275531. Who are you guys?
Hi, just introduce ourselves. My name is Rob, and with me is Luke.
Hi.
We're on basically we call it a threat hunt team here at the firm we work for, and basically we run our own Ceph cluster. So it's not like enterprise-wide as in like the entire firm. It's just something that like the two of us and another person basically we run to do a lot of our data analysis and data storage and things like that. So we've been using Ceph now for I think about 2 years. But recently, and we don't know if it's recent because like has anything changed on our setup or is it just new bugs or new performance issues? But recently we've been seeing quite a few performance issues, mostly on the RGW side. And we've tried everything, at least in our mind anyway. I'm sure we haven't tried everything. Otherwise, hopefully there's a solution. So our hope was that we could kind of go through like what our setup is, what our use cases are, and the bad behaviors we're seeing.
Yeah, absolutely.
Did you want us to start just with the setup first, just so you kind of have an idea of like how we have things architected and go from there? Whatever's easiest for you. You let us know like what's most fruitful for you.
Yeah, sure. Why don't you talk a little bit about your setup and kind of the just the order that you gave is just fine. Go ahead.
Okay, cool. And please, obviously, if there's any questions or more details, just please ask away. And we tried our best to gather as much information we could before this call. And we've been doing a lot of testing over the last probably 2-3 weeks. And we kind of both came to the conclusion that it's probably best to hopefully talk to some folks that know more than we do. So we're hoping you have some ideas for us because we're definitely a bit frustrated. So our setup is we have 120 nodes in our cluster. Each node has one OSD each. Our OSD is basically a RAID 5 24 drive setup. Those are just spinning disks. We wish we had better, but that's what we have. Total size of the cluster ends up being roughly, call it like 3.5-ish petabytes. So, a decent amount of storage. You have information on the placement groups?
So we have like 9,700 placement groups in 9 pools, but basically we have a RBD pool and a RGW pool.
Yep. For the RGWs, we originally had roughly 10 RGWs spun up. We've gone up to 21. It may have helped things slightly, but not anything I would say super noticeable. We are on version 14.2.4 for Ceph. One thing to note, though, is that our boxes are not like dedicated just for Ceph. It's actually, is multi-tenant. So there's other things running on those boxes, other jobs and other workloads. So we don't want to make it sound like, these boxes are just dedicated just to running Ceph. So they are not. Those boxes are running Red Hat 7.6. Kernel is 5.2.3. Networking between them is 25 gig between all nodes in the cluster, even across racks. The memory footprint is we have about 768 gigs of memory on each box with about 80 CPUs each. Any questions about our setup before we kind of dig into the use cases and the issues? I think that those are the major things we wrote down, but is there anything else you'd like to know?
No SSDs in the systems?
No, unfortunately. We have at least put in
Okay,
for, we're hoping to get the NVMe so we can do things a little bit better for the metadata, but we right now do not. Believe me, we wish we did, and we are pushing hard to try to get them.
sure. Uh, are these hardware RAID controllers?
Yeah, yeah, they're Dell servers, and it's using the 730 mini RAID controller.
Does that have battery back cache?
Does it have write back cache? It does.
Does? Okay, and that's enabled and everything.
It is.
Okay, cool. Um,
I just question while you're right there is like, the read ahead cache is also enabled and adaptive? Is that a good setting, or should not be adaptive? I don't even know for this setup.
to be honest, I don't think it's going to make a whole lot of difference. At least I haven't
That's
seen
kind
it
of what
in
I
the
thought,
past.
but figured since you were right there, I'd bring it up.
Yeah, it's been a little while since I've really gone through and tested like hardware RAID controllers. So yeah, it's possible some things changed since then, but the last time I tried it, it didn't seem to do much of anything. At least
Okay.
for our purposes. Um, let's see. What are you using, Blue Store or File Store?
Blue Store.
Okay, cool. How many buckets do you have?
So real quick, before we get into the buckets, just so you know, on the RBD side, things have actually been running really well. Our main use case there is we're mostly using it for Elasticsearch, so heavy ingest searching as well. And for the most part, like we haven't seen any I can't characterize the performance as perfect, but at the same time, like no like major issues there. So just want to let you know we are using RBD, and like that side's been pretty solid. Like no major concerns there at all. But yeah, let's go into the
Yeah.
RGW side of things.
We have about 3,000, maybe 4,000 buckets total.
Okay.
And so, per bucket, like, some like the big buckets that we read and write from or read from a lot maybe have 1.5 terabytes is like our biggest bucket in size with like 160,000 objects. So it's that kind of range. Most of our buckets are smaller in size than that, but that's kind of like our biggest ingest goes into a bucket that has 1.4 terabytes, 160,000 objects. We have another pretty active bucket that has like 100 gigabytes and 500,000 objects. I should say that like on all the Ceph.config, the only thing that we've actually changed from like just the defaults that came with 14.2.4 is we've changed the dynamic resharding to 150,000 versus 100,000. That's the only change we've made.
And we did that only when we were trying to like improve performance. Like that wasn't something we would have normally done. Like we had it at 100,000. We were like just grasping at things that might be causing our issues. So we tried that, but I don't think it really affected anything, positive or negative.
Okay. So where are you seeing performance issues? Like talk a little bit about your
Yep.
workload.
So
And
let
what
me
you're
just
seeing.
talk real quick about the use case we're seeing those performance issues, and then we'll get right into like what we're seeing. So I would say the two main use cases we have is ingest, where we're getting data into RGWs, and the good news is on ingest, I would say we are seeing 0 performance issues. To give you a characterization there, we're seeing roughly when things are in a steady state, 300 to 600 requests a minute, I would say. And what we try to do there is we chunk or we merge our data as big as possible, so we don't have like a ton of objects. And that's where we're talking
Sure.
basically like in a given day, it is a couple, a terabyte or two of data, but the number of objects for a given day is only in the like, low 100,000-ish, range in that area. And that ingest has been going great. The area that we're having issues is when we actually are trying to use the data to do basically like big data analysis. So what we're doing there is we are basically writing distributed Python jobs. I know it doesn't really matter which language, but bottom line, distributed analytic jobs. And basically most of those jobs, the way they work is they usually work on a day's worth of data. So stage one of the job is basically read in a bunch of data for the day from one of those buckets we just talked about. And at that point, we're probably doing about 100,000 requests a minute, and just loading that data into our Python script. We then obviously just do some actual analysis and processing, and then once we process our results, we try to then there's a pretty large amount of writes to basically take those results and put them back into S3. At that point, you're probably also in the 60 to 100,000 requests a minute. And what we are seeing is that basically when we run these jobs, not every time, that's what we've kind of been joking about. The only thing that's been consistent is no consistency. There's times we run this and things run just fine and things finish fine and latency looks great. But then often enough, that is not like a fluke. Basically what we will see is the latency, our median latency is usually like 0.02 seconds and like things are great. But when we start seeing things to like eke into bad territory, but our job will still finish, latency median or maximum will be about 50 seconds. And when things go really bad, the latency maximum will go up to 120 seconds and things start getting real bad then. In those cases, the median is like, when things are really bad, about 2 to 4 seconds. So we see basically a degradation there. And then ultimately what ends up happening is we usually see a bunch of timeouts happening first. And then eventually we are actually seeing seg faulting RGWs where it just dies. We've tried to scour every log we can to figure out like what's going on with that seg fault. We even added the logging to 10 on the RGWs, and basically what we see in the log is things are running fine, and then all of a sudden basically just stopped in its tracks and just died. We've had some jobs so bad that, again, it's not consistent, but we've had times that we ran a job and we had in a short period of time, at that time we were using about 10 RGWs, we had like 30 restarts in that short period of time. We actually killed that job because it basically looked like nothing could stay up. But bottom line is the symptom we're seeing is that under some type of load condition, we're seeing seg faults and definitely degradation of performance and latency before that, and then ultimately these seg faults. Am I characterizing it well, Luke, or is there?
Yeah, I think that's good, and also, I mean, we've kind of throttled the amount of trying access to those buckets to get it to actually perform. So, if we kind of hit it with as many workers as we want to do the distributed reads, I think we would get this behavior sooner. So this is kind of at the manageable level where most of the time it finishes, we still are getting these seg faults, but we'd really like to even do more and have it.
Yeah, right now, at least with our jobs, our absolute bottleneck is basically the RGW communications. And then other things just to note is that when things get really bad, we've definitely seen degradation across the cluster, basically. So like trying to DU the bucket will just not happen. Surprisingly, the writes don't seem to be affected that much. Like I don't see our ingest getting affected deeply by things, but like doing reads from it have been affected for sure. And just bottom line is that we did try Civic Web, and because we're using Beast right now, and things were probably worse with that. We just ran 1 or 2 tests, and things were crashing right away. So we did try that to go away from Beast just to see if that was a problem. We were seeing this problem down. What version of stuff were we using before we did the upgrade?
14.2.1.
Yep. So we just tried, going to the latest to see if there were any hopeful, like maybe if there's a bug or something. And our IOPS, just so you know, those don't really spike during this. That's one thing like we're kind of not surprised by, but it doesn't appear to be an IOPS issue. Our IOPS usually stay about 1,500 to about 2,000, and during these events, we don't see like a huge spike in IOPS or anything like that. We have seen some cases where it happens, where we start getting weird random errors from the RGWs, like 206s, 204s. We've had times where a request will come back with Unicode when we requested a bucket. So like, it just seems like things get into a really weird, bad state where like you can't really, understand what's really going on. And then other times what's kind of interesting is we'll be running a job, this behavior will happen, we keep the job running, and it kind of like calms down at some point, which is also kind of weird. So again, it's one of those things I can't really tell you like what exactly triggers it. But, and again, we've sometimes ran the same exact job with the same exact data. We try to be scientific about it, where we like basically blew away the bucket that we were writing to, ran the same day's worth of data, which should be, pretty much the same workload. We've made sure that we're hitting the RGWs in a very uniform manner, so like one RGW is not getting overloaded. And we've absolutely had times where we run the same exact job with the same data, with the same empty bucket we're writing to, And in one case, it ran just fine. In another case, basically we had RGW crashes happening.
Okay. So the fact that you're seeing like super long max latencies, the thing that we've seen internally that sounds a lot like is what happens when a bucket is resharding, like for like a bigger reshard. So I guess one question I'd have for you is it possible that your workload, when you're running that analysis workload and doing both reads and writes, that you're pushing it over the resharding threshold, like whatever the next resharding threshold is?
So we thought that might be happening, which is why we moved the dynamic resharding to 150,000. And the tests where we were seeing this, all the buckets involved were staying under 150,000.
Okay. Okay. Are you guys familiar with GDB and looking at core files?
It's been a while, but so I mean, as an orchestration level, this is like these are being run in Kubernetes. I don't know where the core files actually go at that point.
This is in Kubernetes.
Yeah.
Okay. That throws another twist into this.
Yep.
So we have seen behavior that sounds a lot like this in Kubernetes. And this is not RGW specific at all, because it can happen on the OSD and other things too. If you run out of memory in Kubernetes, unless you guys have found a way to do this, you don't get swap space. And we've seen cases where basically when you exceed the amount of memory that is available, then you start basically paging out parts of the application, and you get these ridiculous, horrible stalls that sound a lot like what you could be seeing here. Out of curiosity, how much
memory like on the RGW like node or pod for us? Because we don't see out of memory kinds of things, or even memory being taxed at all.
How much memory are you assigning in your container for, or how are the containers set up? Like how do you have, the diamond?
So we're using Containerd instead of Docker. So that's one thing we are doing. I don't know if there's any issues with that. And we can check what our limits are set to. We definitely have limits set. And then we're using Rook to do our orchestration of like Ceph on Kubernetes.
Okay. Any idea what you have?
If we were going beyond the memory limit, we would definitely see logs about it trying to reap the pod, and we don't see anything like that. And when I like log into the pod, like with RGW, the load is like 2 or 3, and the memory usage is not at all like extreme. That's not to say that some other limit like that's hitting below like the system limits that is causing this, and we just don't see it in any logs. I mean, if some log pointed to that, we would love it, be able to have some evidence of that.
When you say a load of 2 to 3, is that consistent or is that like a peak?
So I think a peak is probably like 3.
For a given RGW. And it's consistent among them. We aren't seeing, for instance, one RGW that's like higher than the rest, like by any, statistical, method. Basically, it just looks like they all are kind of uniform. And like we said, we thought at a 2 or 3, I don't think they're being taxed that hard. But maybe we're wrong.
Yeah. If you're not seeing like, stalls at the container level, like, with even like just trying to log into it or something, is probably not what I was describing then.
No, we don't get that at all.
Yeah, we can get into the containers, no issue at all. And everything, and we've been on the actual like box that the container's running on, and that seems fine as well. Like we've definitely seen in other cases, not with Ceph, but other parts of our stack where we've had issues like that, and you're absolutely right. Like everything just becomes like sluggish and overloaded. We haven't seen that at all with this. It's kind of like, just something triggers this bad performance, and then all of a sudden, a seg faults.
Yeah, I mean, like
Hmm.
the RGW pod will restart. If I log into the box under D message, be a couple lines about the seg fault, but no other detail. Nothing leading up to
Yeah,
that. Nothing in varlog messages or anything.
yeah, and it's I don't actually know how to do GDB and actually get like core dumps out of stuff running in containers. It's the last time I heard anyone talking about it, it sounds like it's a pain in the butt. So you might have your work cut out for you. But if you can
Is,
get
is there
one,
is there any like listening to like the size of our cluster and kind of the workload? Are there any like vanilla settings in the Ceph.conf that should be tweaked? Because we're just like whatever the defaults are. The only change we've made is the resharding threshold.
And again, if there's anything even in Beast that we should be configuring, like we couldn't really find a good document of like what to even configure in Beast. So like again, all that's going to be vanilla, which maybe for our size maybe is inappropriate, but we just didn't know. We did at least find a Red Hat document about some OS settings to change, and we did try those, but those didn't seem to really have an effect one way or another.
Those
well,
involve
from a
like
really high
changing the network message size and some transmit receive buffer sizes and concurrent connection kind of things. There's a handful of OS settings in sysctl that we made, but we didn't see a change.
I guess from a high level, one thing I would say is okay. So the way you guys set up, you've got 24 disks in a RAID 5, and they're all sitting behind one OSD. Um, that kind of setup kind of makes the OSD itself kind of a point of contention, right? Rather than having like 24 OSDs running on 24 individual disks. Now you've got one that is sort of faster in a way. Um, but also with RAID 5, you're going to be introducing extra latency for small operations. So, it'll be faster than one disk certainly, but you're not going to get the kind of like, throughput, especially like, IAPS throughput that you would from those 24 disks, each running with their own OSD. You're also going to be really limited in terms of, by default, you'll have like 4 gigs of memory for that one OSD, but you may want to consider, since you have tons of memory, it sounds like, just bumping that way up. You could set an OSD memory target of like 16 or 32 gigs, and it sounds like you'd still be way under what you've got. Does that sound right?
No, that sounds like something that is definitely.
Yeah, absolutely. We could try. I mean, like I said, we're not hurting for memory on our machines, which is nice. And yeah, absolutely.
So the Ceph.conf
Yeah.
variable there is something like OSD memory is in the name of the variable?
Yeah, it's OSD memory target is the name, and by default it's 4 gigs. I don't remember how that works with Rook. I know that there was recently some discussion about that because it's sort of I think it's trying to like automatically set it to the container size or something. So that would be another thing to check to see how big
Okay.
your container is for the OSD.
Absolutely. No, we'll check that out.
All that stuff. But definitely, the more memory you give it, the more like onode cache you get, the more RockCB cache you'll have for caching OMAP data. And if you're doing something like thrashing the cache by trying to like read new SST files in constantly, just because you've got like lots of objects in RGW, the more of that you can keep cached, the better. So
Cool.
that definitely would be worth looking at the very least.
Would
Might
you
not fix
say
it,
it's
but
highly worth looking at changing our OSD structure? Like, do you think that's like on the top of the list? Would you recommend doing the one disk per OSD or somewhere in between where we maybe make a few smaller raids? Like, we're open to suggestions. We just kind of were trying to go the simple route, so to say, but that doesn't mean the best route. So do you think it's somewhere in between, or do you think we should go all the way to the one disk per OSD?
what kind of replication are you doing and stuff right now?
On the RBDs, we're using coding. I don't remember the setting exactly. And on the RGWs, I think we're just replicating one.
Okay, so you have one replica or like one extra,
Yeah.
so it's like 2x.
One copy.
Okay, so that's an interesting question. Kind of typically we tell people just to do 3x replication with one disk per OSD for like hard drives. There's been in the past folks that have done like 2x replication and then do like 6 or 8 disk RAID 5s or RAID 6 arrays, and that can work. I guess I would be tempted, if I was going to redo it all, to just do the 3x replication with one disk per OSD and see if it's better. I suspect it may be. But having said that, it's really easy to start out with just tweaking the memory, right? You don't have to read.
No, absolutely.
Yeah.
Totally. I'm just trying to get an idea of like, if memory doesn't work, it sounds like it absolutely is worth trying. And this is a system, we luckily have a spare that has our data that we can start over at some point. So that's not like out of question. Obviously not like ideal, but if it gets our performance up, it absolutely is worth it to us.
Sure. And depending, do you know for your workload, are you doing a lot of bucket listings as well, or is it just bucket?
I wouldn't say a lot. I mean, we do them. It's one of those things usually like in the beginning of the job, we do a listing. We might do another listing or two, but it's not like hundreds of listings. I think that's fair.
I think that's right.
It is a handful. When I say a handful, say 10 or less per job.
Okay. Yeah, that probably shouldn't be an issue then. I don't think. So yeah, I guess the next question then is, yeah, so like during these pauses, do you have any insight into like what's going on? Like, is RGW doing a lot of work? Is the OSD doing a lot of work? Like, can you see in top that it's using a lot of CPU, or is it pretty idle?
So we've been doing all our testing on our kind of spare data center, so to say. So the only really workload happening on that data center in general is we are ingesting data into obviously into our S3 and into Elasticsearch, but no one's really searching anything. No analytics are running on that thing. So I would say it's kind of in our quote unquote steady state. And that thing's just kind of humming along. And I even we have like Jenkins that runs different jobs and stuff. And we even look like when one of these bad behaviors happened to see did something happen to run in the cluster that we weren't aware of. So honestly, we believe things to be kind of calm in general on this cluster. And at least when we were doing tops and stuff of loads on the boxes that had the RGWs, we didn't see a spike on the actual box that I can think of.
I mean, I actually didn't look at the overall load changes across the OSD pods. Is that something that maybe we could look for, I guess?
Yeah, I mean, just anything that you can see in terms of system metrics. If there's anything that would.
We were definitely focusing on the RGW.
Yeah. Only because we weren't seeing IOPS or anything like that changing, so we weren't sure. Does that mean the problem absolutely is at the RGW level? We just weren't sure because everything else seems to be behaving fine.
So when this happens, when RGW is stalling, you can still do RBD writes and it's totally fine.
Yeah. Yep. Yeah. And in fact, when these have been happening, we do our ingest using NiFi, Apache NiFi. And when we actually looked at when this was really bad, I kind of looked at our ingest even into RGWs and then our Elasticsearch was the RBDs. And in both cases, our ingest was just fine, which is kind of surprising. But we have seen cases where when it gets really bad, we have some Jenkins jobs that will just download a binary from S3, nothing crazy, and some of those were timing out. So it's just really odd that I really would have thought when it's in the really, really bad state, our ingest on both Elastic and S3 would have been greatly affected. But maybe there's a timeout or two, a minute maybe, but nothing that's causing things to backlog or anything like that.
Interesting.
Which, yeah, to us, that's really weird to us. Why is that not being affected?
Yeah. So, unfortunately, I wish Casey were here because I have some thoughts on the seg fault you're seeing. Adam, have you guys seen anything that sounds like what they're seeing with seg faults like this? I haven't seen it in my testing with RGW recently, but anything on your guys' end?
Where are they seeing it?
They're it's like almost random. It sounds like where they've got like they've got an RBD workload that's running fine, and then like periodically, almost randomly, it sounds like RGW will stall out, and then eventually segfault. Beat with the beast front end.
And we've tried also, like I said, with Civic Web as well, and it happened with that as well. So we did try both because we were like, well, maybe something with Beast, and we were able to replicate it actually pretty quickly. Our first try with it crashed one almost immediately, I think, within 5-10 minutes.
I haven't seen anything like that. I've found a couple seg faults, but they were very deterministic and in specific areas of code, and well, also fixed them. Like if you could give us more details about the workload, we could try to reproduce it.
We're trying our best with that. That's everything we probably should have mentioned. So like we have an analytic that again doesn't do it every time, but it does it. Say if you run it 10 times, you're almost guaranteed it'll happen at least once. So what we tried to do was write a very, very simple thing that we thought was kind of replicating what we're doing. And when we wrote that thing that, is doing some reads, some writes to the same buckets, and just like instead of doing, actual analysis, we were basically taking data and just moving it and things like that. And when we tried doing that, it was much harder to make it happen. Not saying it never happened, but it wasn't like we were like, oh, if we just pound it hard enough, it's going to just fall down. And it didn't necessarily seem like that was the case. So we're a little confused by like what is the actual environment that's causing this thing to trigger.
Yeah, I mean whether it's just some of the timing that the actual analytic does between reads and writes and the actual numbers and sizes of the objects going around, it seems to hit it. I mean, in a I'll get an RBD. I mean, I'll get a RGW seg fault. Probably on average every third run. But I'll get a slowdown probably every other run that's pretty significant. And if you're using like Python using requests, I'll get hundreds and hundreds of timeouts trying to get to S3 interface. And then when those hundreds become 500 or 1,000, often it's corresponding to one of the RGWs that's seg faulted. But it's pretty common. I'll get to slow down in the middle of the job. I'll have hundreds of retries from a Python request perspective, trying to access stuff in S3.
And we've even tried things in our code where we say like once we call it timeout happens, we switch to which RGW we go to and things like that, trying to like isolate the bad one. But like any of that code we've written, it doesn't stop it from happening because obviously other requests are still going to go to that bad one. Or maybe not bad one, the one that's in a bad state.
And which version are you running?
14.2.4.
14.2.4. I mean, the main thing I would think of right now is just to try to maybe try to open a bug. Maybe if you can, if it's feasible, maybe try deploying a debug build or something like that, and seeing if we can get a more detailed core dump out of it. Or a detailed core dump or stack trace or something like that.
They're running inside Kubernetes, Adam, which makes it even. I don't even know how to get a core dump out of it, to be honest.
Oh yeah, I'm not sure how to do that too. Containers are special and magical in that sense.
They sure are.
So I guess the homework for you guys. Oh, go ahead, Adam.
I was going to say you might want to come to the RGW core stand-up and mention it there. Or sorry, not the RGW. The RGW. It is 5 minutes from now.
Cool.
And it is also on. It is also on Blue Jeans. I can give you the number if you like.
Yeah, please. That'd be awesome. We will do that immediately after this.
It's not actually a stand-up meeting. We have a bunch of things that are called stand-up meetings that aren't. It's like they're more than 5 minutes long and everyone sits.
I know the type.
All right, you want it's in Red Hat or it's on BlueJeans.com. The meeting number is 113-831-263.
Awesome. Cool. And you said that starts, I guess, at 11:45 Eastern time?
11:45 every 11:45. They're daily, but the time changes day by day. We have some that are early morning by my time and late evening by
Gotcha.
India time to be more APAC friendly or APAC friendly. We have some that are more East US Europe friendly.
Okay. Excellent. No, we definitely could call them like in a minute. That'd be great. Unless you all had anything else, we're definitely trying the memory. If we can do a rebuild, we tried the OSD. Are there any other settings or anything at all you all can think of? Or I guess maybe the RGW folks might have some ideas of maybe what we could tweak inside of Beast.
Yeah. I mean, the only other things I was going to
the main
suggest
thing
would be the if you thought there's a chance it was the dynamic bucket sharding, to disable that completely and just see if it worked. But
Sure.
for the bucket that
That
you're
would
testing,
take it out of
but
the picture.
yeah, but I mean, it sounds like you guys are have some evidence that that's not what's going on. So
That's what we believe. I mean, we don't see anything in the log saying any dynamic sharding is happening during the jobs, but I mean, at the same time, we could try it.
So yeah, I mean, that could be something you could try.
And if you could find some way to get a decent backtrace out of Kubernetes, that would be the most useful thing, honestly.
No, 100% with you. We might look into that. If nothing seems to work, we can talk to some folks about that, how we could get any. Yeah, because you're right. Right now, unfortunately, the log message we get is basically seg fault with no details that are interesting at all, unfortunately.
Nice hex stack pointer number.
All right. Well, yeah, I'd say.
Well, like I said, we'll give the other call a try, and we will try some things out. And if you all don't mind, maybe one way or another, if we have either positive, negative, or some news, we're calling again and just let you know. Just so it's always nice to have a little closure, at least I find. So we'll let you know, and we're definitely and maybe you come up with something that you say, oh, we started seeing something similar, and absolutely, if we ever come up with a simple thing that can replicate it at all, we would absolutely be happy to share what we can. So we just wish we could find what that thing is. But again, we really appreciate all your time, and at least you got some leads for us to at least track down a little bit. And again, we report back if that's cool with you all.
Absolutely, yeah, definitely. So certainly in the RGW stand-ups, if you attend those, and also next week here, it'd be great if you could let us know what you find.
Yeah, absolutely. We have any Yep.
Oh, I was gonna say just quickly, since I know you got to run to the next meeting here, but if you could document what you're seeing in the tracker, create a new bug there, and even if you don't know what it is yet, but just could write down some of the things that you've told us now, just so that we can start getting, keep that in the system and have a record of it. That would be really useful.
Sure. Yeah. We're happy to do that. We try our best to try and make sure we're giving back to the community in any way we can. So no, we'll do that today or tomorrow.
Cool. Thank you.
Yeah, we really appreciate it.
All
Thanks
right.
again, and we're trying this next one. Again, thanks for the leads, and we hope to talk to you soon with some good news. Thank you.
All right. Well, good luck, guys.
Thank you. Bye.
Bye-bye.
Bye-bye. All right. Well, I think looks like everyone else is left. So, Philip, it's just you and me now. Anything else?
No, I'm just sitting in, just trying to see what you guys are up to with performance. I'm from Seagate, doing smart autonomous storage devices and looking at Ceph and embedding Ceph and those kind of issues, and just kind of looking at what you guys are doing in the way of performance. And so I just thought I'd sit in for the next couple of weeks and just kind of listen in and see what you guys are up to.
Oh, neat. Cool. Yeah. So today is a little bit slower than normal because we got a bunch of people out. But right now, a really big topic for us is metadata and how we should be storing kind of the massive amount of key value data that we can generate, for a given OSD. So, things like, persistent memory,
Hmm.
RocksDB, some of the efforts that I think some of the companies now are making towards having like an NVMe key value interface.
Correct.
Those kinds of things
That's
are really interesting.
I definitely work in all of that space. I attend the NVMe key value meetings for Seagate, and also work with the Kinetic team here doing key value inside the drives. There's some optimizations that can be done in the drive that can't be done outside. So that's my interest about, pulling in the data management into the drive is because it's so tightly connected. But Ceph's memory footprint's a little big, and we're trying to figure out
Yes.
where those pieces are and where we might do some optimizations. Also, I work with UCSC, and I don't know if you've ever heard of CROSS. It's the Center for
Mhm.
Research on Open Soft. Well, we have a program there called uSocial Storage, and that's based around the idea of putting a system that gets rid of the OSD server, right? That you can have these drives be the OSD essentially,
Sure.
and just allow you to rack and stack these drives, right? But we have to
Yep.
figure out some of those memory issues before it becomes practical. But
So,
I heard from
go
David
ahead.
Byte. I heard from David Byte of SUSE that he's gotten memory footprints down to like 2 GB in OSD right now. Have you heard that?
Yeah, you certainly should be able to. The trick is shrinking it while simultaneously not hurting your performance really badly.
Right. Right.
Um, One thing though, that if you guys are interested in that, the I think going forward, the one of the big questions we have is right now we keep the PG log, basically the log of recent operations on a PG in memory, and we write it out to disk. But that's not going to work long term, especially as devices keep getting faster and faster. Or at least in my opinion, it's not going to,
Yeah.
because you can't keep a log of any real length of time in memory. It's just you're going to consume massive amounts of memory trying to do that. So we have to make it somehow have some of that log in memory, while other stuff we go back and read from disk later if we ever need to use it.
Right.
So
I'll take
that's one thing.
I'll take a note.
But then more generally, just things like, okay, you've got a bunch of different kinds of data that you want to cache, and how do you decide what to cache and what not to cache, and what's important at any given point in time. So I've done a fair amount of work in that area, but that's kind of the question is,
Yeah.
if you're memory constrained, how do you make those decisions?
Right. And then the final piece that makes it worse, the memory situation even worse, is that the ultimate goal for uSocial storage is to leverage like the object classes to do computational storage in the device.
Sure.
So memory then becomes even more of a premium because you need to save some for processing other things.
How much memory do you guys have to work with?
That's not defined right now.
Okay.
But you can kind of imagine the problem we're faced with is that traditionally components are always valued within the component box, right? In other words, how many gigabytes per second? What is the failure rates? What is the cost per gigabyte? It's very hard to get people to pull back a level and say, all right, now let's look at what the system cost is per gigabyte. And even though I might increase the cost of the device, am I overall saving money in the environment by not having to purchase things, by reducing network traffic, by getting rid of provisioning of network components, that kind of stuff. If you could actually legitimately make that argument, meaning people would listen, then you could put more memory in this, right? You could take that memory that you normally would have had in the system and distribute it across all the drives, right? I could take 4 gigabytes per OSD and put it inside the device, and maybe even a little more.
Sure.
And I think we're headed that way in the long term, because as we start going to more composable systems, the network traffic transmitting stuff back and forth across the network, huge data sets, is just going to get more and more costly. And also you start hitting bandwidth limitations of DDR inside the system when you start talking about SSD transfer rates, where
Yep.
now if I can distribute these data loads across 1,000 DDR buses instead of just one DDR bus per proc, right, on the host,
Yep.
I get a huge benefit, right? So,
Yeah, absolutely.
so anyway, that's what
So,
we're
yeah,
looking at right now. It's definitely futuristic, but we're trying to move the ball slowly in that direction.
cool. Well, yeah, definitely. Feel free to stop by for the meetings that we've got here, and I'm not sure exactly what we'll be covering in the next couple of weeks, but some of the things that have recently we've been going over are like switching to the smaller min-alloc size for the OSD, or for Blue Store rather. Some of these kind of RGW things that have come up recently that may or may not kind of become a focus again here. But then they also generally NVMe performance and kind of key value storage and all this kind of stuff. So happy to have you.
So I'll just be sitting in, kind of being a fly on the wall for a while.
Okay, sounds good. Well,
All
nice
right.
to meet you, Philip.
Nice to meet you, Mark. Talk to you later.
Yep. All right, have a great day.
Yeah.
Bye-bye.